Hello everyone, once more welcome back to Z Lessons. In this video we are introducing a new topic, a new lesson that is taught in grade 11. I don't know if it's now called Form 2 or Form 3. I'm not quite adjusted to the new naming system, but yeah, it was taught in grade 11. This is Circle Theorems, and we are going to answer different questions at the end of this playlist. So this is how I divide this video. In part 1, we are going to deal with the introduction part, the introductory part, where we are going to learn different concepts such as what is the circumference, what is the radius, what is the tangent, the chord, segment, sector, all that interesting stuff. After we are done with all the basic terminologies and all that stuff, we are equipped with all that terminology, then we are going to dive into part 2. In part 2, we are going to learn different theorems that we are going to use to answer different sort of problems, and these problems will be found in part 3. So in part 3, that's where we are going to now solve the different examination past paper questions involving the theorems. So to recap, in part 1, we're going to deal with the terminology. We're going to understand what this is called, what that is called, and all that stuff. After we are done with the introductory part, we're going to dive into part 2, and in part 2 we are going to learn about the theorems, the different theorems to come up with the answers that we are going to solve in part 3. So that's the flow of this lesson. So now, having said all that, I highly recommend that you pause this video in case you haven't downloaded this book. It's free and it's published by Z Lessons. You can find it in the video description below. So you can pause this video and find it in the video description. You will see and find a link that will take you to Google Drive, where you are going to download that file from there. So having said all that, let us begin. So now, since this lesson is called Circle Theorems, it only makes sense if we understand what a circle is. Otherwise, why would we attempt even answering this question if we don't know what a circle is? So let us dive into what a circle is. As you can see, this book has everything that you need. All we have to do is go at the section that's talking about the circle, and let us read the definition. So what is a circle? So this is the $1 million question. What is the circle? A circle is a two-dimensional shape. By two-dimensional, it means that it has a height and a width, and the height and width are obviously the same size. That's what makes it a circle, okay? So a circle is a two-dimensional shape in which all points on the circumference or the perimeter are equidistant from the center, as you can see from these diagrams below. So now, in order for us to have a very interesting lesson here going on, I'm going to head to my software here called GeoGebra. This is where we're going to find various tools. I'm going to use this tool extensively to demonstrate all the concepts here, so that you can get a grasp and solid foundation for the topic or lesson at hand. So now we need to find a point. So let us just head there and choose this point like so. I'm going to name this as center. Let me just name it. Let me name it like so. Okay, center. I don't know if you prefer me writing center like that or like the other way around, but let's just leave it like that, center. So now that's the center. So now we need a point to represent the points on the circumference. So let us add a point like so. So we're going to name this as a point. Let me just name it as point. Okay. So now we have named it as a point. Let us just change the color so that you can better see the difference. Let us just change it to a red like so. So now this is all we need to define a circle. So now the definition rather said that a circle is a set of points, infinitesimal points, if you want to get that excited about the lesson. So it's a set of points that are equidistant from the center. It involves two words. It involves equal and distance. So the distance is equal. That's what equidistant means basically. So let me add a line segment like so, just to represent the distance. Now let us measure it. We go where it says measure, and we are going to measure the distance by just clicking there. So as you can see, the distance is 4.7 units. Okay, units. So now the definition says that this point all the way, all these points, by the points I mean all these points, when I begin to drag this, it represents all the points around the circle, or should I say around the center here. So all those points should be the same distance. The distance is 4.7. So in this scenario, all the points should be the same distance. That's what it means. So now, as you can see, when I begin to drag my point, let me just change it by clicking that icon. So when I begin to move, as you can see, the distance is changing, which means that when I begin to trace out the points, they won't form a circle. So this is what I mean. Let me just go where it says show trace and begin to trace the points like so. As you can see, since the distance between the point and the center is not the same, it's not equal, I'm not forming a circle, no matter how hard I try, because the distance is not the same. It varies. Sometimes it's 4 point something, sometimes it's 5 and all that stuff. Sometimes, as you can see, it's not a circle. This is not what we want. So by definition, that is not what's this? That is not a circle. So in order for us to have a circle, the points around the center should be the same distance. So that's what I mean. So let us say we add another point. Let us put a point like so. Then we draw a line segment like so. Then let us measure the distance. Is it the same distance with this? No. So which means this point doesn't lie on the circumference. So in order for this point to lie on the circumference, it should be 4.6. Let us see if we can achieve that, as you can see. So now this means that this point here, point A, lies on the circumference. Let us add another point. I'm just doing this so that you get the idea of the concept of what a circle is. Let us measure it. Let's measure the distance. It's 3.4, so it's not the same distance. So let us see if we can reach it towards 4.6. So this means for B and A are points on the circumference. So now let us prove that. Let us create this circle. So let us do it like so. And as you can see, wait for it, as you can see, just like magic, the points that we are from creating lie on the circumference. So that's the circumference of the circle. As you can see, this is wonderful. This is wonderful stuff. Okay, let me just get rid of that point because it's not needed for now. As you can see, point A and B lie on the circumference. So now, this is what a circle is. A circle is simply these points. This point here, this point there, and this point there. All those points, if we add an infinite number of points on the circumference, they all should lie the same distance from the what? From the center. That's what it means when they say a circle. So now, just for fun, let me just get rid of this so that you can see the final demonstration. Let us say we create a circle like so. Okay, I want to show you what they mean when they say infinite points. This is point C. Okay, this is point C. As you can see, when I drag it, this is point C. Let me just change its color to red. Then let me add the line segment like so to show the distance, and let me measure it. As you can see, it's 4.8 units. Now I want you to see what will happen when I trace it. Okay, before I trace it, let me just animate it like so. As you can see, by the way, a circle has an infinite number of points on the circumference, as you can see. So that point C is representing all points, and as you can see, all those points are the same distance, 4.8. And as you can see, they're forming an outline, which is the circumference. Now let me enable the tracing feature and play it one more time. And as you can see, you can now see all those points being traced out. So as you can see, this, my friend, is the definition of a circle. A circle is a set of infinite points. As you can see, all those are the infinite points being traced out like so. As you can see, this is a very, very interesting lesson. All those points are lying on the circumference because they're the same distance. So my friends, that's what it means when we say a circle. Now for this video, we're not going to dive into what is the pi and all those ratios. We're just going to end here. So now let me do one last thing, and we are going to call it a lesson for today. Let me show you what will happen if we do not have the same distance equal for all points. Okay, so let us go where it says conic. Let us find some conics here. We're going to find this ellipse. Then let us say we add a small circle like so. Yeah, I just want to demonstrate something really quick. So let's say we add a point like so inside this small circle. Now as you can see, it doesn't appear to be a circle, but we want to prove this mathematically. So let us measure the distance between F and D. As you can see, the distance is what? 2.6 units. So now look at what will happen if I begin to drag point F. As you can see, the distance is not even. Let's say all these points around this, let me just color it like so in a blue color. So let's say all those points around this circle, we refer to this point. This is the center of all these points around this blue outline. So as you can see, it's not the same distance. As you can see, the points that will lie here are the smaller distance. This is why we're getting a 1.4 units, whereas the points that are lying this side are having a big unit, which is 4.1. As you can see, 4.1, 1.4. As you can see, this is why we're not having a circle. Whereas if I drag this one, as you can see, it's the same distance because it's originating from the center, and all those points are the same distance, and so on and so forth. So if I play this, as you can see, this is forming a circle. This outside circle here, this is a circle because all those points being traced out by this red point, point C, are the same distance from the circle. This is point C, and it has a 4.8 all the way. Whereas this smaller circle, the blue one in the middle, as you can see, it has a varying distance. The distance is not equal. But I want you to observe this. Watch as I move this to just form one circle like so, or should I say one center. As you can see, it's now a circle because all points have the same distance, as you can see. So this is what I'm trying to say. So now you understand what a circle is. So because you understand what a circle is, let us dive into the next video, and in the next video I'm going to illustrate and demonstrate what it means when we talk about the radius and all those interesting stuff. So stay tuned and see you there.